Hello everyone. In solar PV installation, the positioning the solar panels play an important role in deciding how much the panel can produce, how much power the panel can produce. So in this context, the angle play an important role in solar PV installation. There are a lot of confusion because there are a lot of different angles we are talking in the solar PV installation, in the solar PV design, and many researches going on with what the positions is more suitable. So if you go and read any research papers, there are a lot of angles they are talking about. So in this video, we are going to talk about each different angle. We are going to explain what is that and how it is measured. So this is a one picture. You can see all the angles in a clear view. So the azimuth angle means that from the north, if you draw the line here, you can simply understand. Simply azimuth angle is from the north. If you extend this line from the north, how much angle we are shifting the panel from the north, how much angle. The same thing, if we from the north, it's a west also the same, because in this geometry, this angle and this angle are the same. So the azimuth angle means we are placing the solar panels some angle from the north. That is the azimuth angle. That's a simple, we can understand azimuth angle. And the next one is tilt angle. Tilt angle is a very famous because all the installation, the technicians know about the tilt angle. It's very simple because more general people, they understand what is a tilt angle. Tilt angle means how much angle you're placing the solar panels from the horizontal. So this is your horizontal axis. This is your horizontal axis. From the horizontal axis, how much angle you are placing your solar panel. This is your horizontal axis. These are all your horizontal axis. So how much angle you are placing this solar panel. And next we need to talk about the zenith angle. Zenith angle means the sun rays, this is your sun rays hitting the solar panel. So at this particular point, if you draw a horizontal line and a vertical line at this particular point. So this horizontal line means, sorry, my the the drawing is not perfect. So if we extend this horizontal line, what is this horizontal line mean? Is not the panel facing in some angle, tilt angle. So if you know the surface, we can find the horizontal line. So from the horizontal line, how much the solar ray is uh, getting from this is elevation angle. So elevation, or we can also call inclination angle. This is your elevation or inclination angle. The rest of this angle is zenith angle. This is your zenith angle. So these are all terms we are using. We will look at one by one so that you can understand more clearly. So the tilt angle here, you can easily understand how much we are tilting the panel from the horizontal axis. It's a horizontal axis. How much we are tilting the panel. That's a tilt angle. Very simple. We can understand. So number of degree that the solar PV are off the horizontal surface. So that's a tilt angle. So as I said, tilt angle is a very famous among the installers, solar installers. They know that how much is a tilt angle, whether it's a 15-degree or 16-degree, and what tilt angle is more suitable for a particular house, because the tilt angle is changed from place to place. I mean, what tilt angle we want to place the solar panels is changed from place to. If you look at here, this is probably about 30-degree or 25-degree, but look at the other picture, this is 45-degree, because it's depend on how much what direction your sunlight is falling into your house roof. So based on that, the designer has to adjust the tilt angle. Okay, this is the first thing. And the tilt angle in a research paper or technical document, we denote it as beta. So this is a tilt angle, very simple. It's a tilt angle. Next one, we can talk about azimuth angle. Azimuth angle describe the position of the module in terms of how many degrees the array from the north. As I said earlier, from the north, how many degree we are placing the panel. So from the north, let's look at, this is your north. Okay, this is your north. How much degree you are placing the panels? So if you put the panels exactly the same area, the azimuth angle is 0. If this is the panel, is azimuth angle is 0, because from the north, what is a panel is placing azimuth angle. But in case if you want to put the panels a little like some angle to here, something like this, then it makes some angle. So this particular angle is called the azimuth angle. Okay. Next we can look at, yeah, in the this again azimuth angle here is represented as theta set. This is your azimuth angle. Sorry, again, the azimuth angle is represented gamma s here. This is your azimuth angle, and your zenith angle is theta set. Okay, and this alpha is your inclination angle. So all in one picture. We are placing the azimuth angle here. This is the azimuth angle. As I said, from the north, if you extend, this is a definition, because many people confuse with this. If you extend this line, this angle, this angle, and this angle are both the same, because it's a geometry principle is like opposite angle. These are the opposite angle, so this is both the same. So from the north, if the panel is placing at some degree from the north, the panel is now placed at, this is your panel, this is a panel. Okay, this is a panel is placed in like this, so that it creates the azimuth angle, that is alpha s. And your sunlight falling on this panel like this. So from the horizontal axis, how much angle is placing, that is your theta set, that's the zenith angle, and alpha is the inclination angle. As I said, you place one horizontal line, and from the horizontal line, how much sun is the inclined the falling solar radiation is making how much angle, that is a alpha. So type of angles, again inclination, we are talking about inclination angle. You can, because it's a one by one, I'm explaining what is the inclination angle. This is making alpha, because as we said, sun rays falling on this particular point. If you draw a horizontal line with respect to the horizontal line at that particular point, how much angle is inclined. That's always in geometry. Incline, or we can say elevation angle, mean how much angle is making the solar ray, making how much angle. So again, is zenith angle here represented here, and the inclined angle. So zenith angle and the inclination angle together will make 90 degree. Okay, so this together, this entire thing will make 90 degree, because we already knows that we are making the the horizontal line and the perpendicular line at that particular point. We are making horizontal line and the perpendicular line at particular point, and we are measuring this zenith angle and inclination angle. So the inclination angle, this is inclination angle, and this is zenith angle, together will make 90 degree. All right, so again, so now the last one is what is angle of incidence. Angle of incidence is represented theta. This is in a particular point, we are receiving the sun ray or solar radiation at a particular point. At this particular point, if you draw the horizontal line and again draw the vertical line, the perpendicular line to that horizontal line is a 90-degree per line. And now how much angle to the perpendicular to that particular point, how much angle the sun rays is making, that is a theta. So why theta is important? Mean we always said like if the solar radiation falling on particular panel in 90-degree perpendicular to the panel, then we can get the maximum output from the panel. So this is your PV panel. Okay, this is your PV panel. Let's say the solar radiation falling in 90-degree with respect to the panel, then we will get the maximum output from the panel. So we always try to place the panel in 90-degree uh, um, perpendicular to the solar sun rays, but we cannot control the sun rays because direction of the sun rays changes from the morning to evening. So it's keep on changing. So at this particular time, at this particular time, solar sun radiation falling like this. So how much angle it's making here, that's called theta. So that's a normal to the surface, perpendicular to this surface, how much angle is making, that is your theta, angle of incident. Okay, so in this picture you can see all these at one picture we can see all the angles. uh, okay, you can understand from, as already explained, you can understand all the angles from this. It is useful when you read different articles or different design concept. They're talking about angles, how much angle we have to place. So it is important to understand basically what is mean by this angle, what are these terms. Then only we can understand when a designer says that the tilt angle is different, or they wrongly place the tilt angle, or something wrong with the tilt angle, or selection of tilt angle, or something wrong with the azimuth angle. So what they meaning to say, what is wrong with the azimuth angle. So you have to change the direction of the solar panels, or those are the things we can understand from this video. That's all for today. Thank you very much. Please subscribe this channel and continue support.